This is the prototype PC board, where the outer ring will be positive voltage that we're using to develop a project, probably 5 volts or 3.3 volts. And if we want a built-in power supply, if we want to make it a more or less permanent board, we could wire in put the components in for our very own power supply here for 5 volts. I didn't include the circuitry for 3.3. I may do that in a later version. And there's your top side of the board. When this board is finished, it won't have these pin sockets on it. They'll just be open, but to create the 3D image, I thought I'd put those sockets in to make it a little more distinctive. But I won't solder them in. Here's the underside of the board. You can see how the outer ring is all wired together as a solid circuit for our positive voltage. The inner is negative. Inner ring, and then rows of 6 on each of these others. 1, 2, 3, 4, 5, 6, and a slot in the center that's wide enough to put regular shape ICs, integrated circuits, on there. We use those a lot. They're spread across from this row to this row, actually. So we can do a lot of neat little circuits on this board and not have to cut custom boards for every one of them. That's the idea. We can build a prototype on here and throw it away when we're finished, or these boards cost about 50 cents, so a piece. So we can just throw them away. We play with the circuit and develop a circuit here, and we don't use it or like it, or we're just experimenting. We can throw the board away when we're finished and not worry about it. That's the idea of the prototype board. Here's the schematic for the board. We drew it up with KICAD, and it's there's quite a bit of work to duplicate all these little, I guess on a real PCB prototype board you'd call them test points or connect points, something like that. But anyway, once you finish, it's all nice and orderly. If we want to take a look at how we laid out the circuit board, then this is more like what the board will look like without those pin sockets in there. And over here we have the area that we can populate with parts for our power supply or not. Otherwise, a standard breadboard power supply will fit between these points here. If you'd like a view of the bottom side, we'll go to view and we'll say flipped board view. Here you have the board from the bottom. Nothing really interesting there, but that's what you got. Okay. The other board is version 1.1 of our dual CPU frequency generator, frequency standard. We've added quite a bit from the original prototype. Added a lot of sockets on this end, or connectors, to be able to put some off-board circuitry on it. And a couple other little niceties that we won't go into here. This is just what the board looked like now in its final version. Here's the master CPU right here, and the slave CPU. This is the socket where the GPS will be located, just to plug in GPS. Our LCD readout will be plugged in here. There's a socket for the keyboard. And we've got the sounder in here, whose sole duty it is to play the NU fight song at the beginning of the process when the machine starts up. There is no place like Nebraska. And it'll also give you a little feedback click when you hit a key. Click, click, click like that. That's always nice. It makes the keys feel more solid. Over here is power supply coming on up through the power, the crystals for the CPUs, both of them. Power supply provides the power for the whole board. This is where the work gets done. This little guy runs the GPS, the slave. This little guy over here, the master, runs the keyboard and the display unit. And we have an LED here for power on now. We've added that. We've got a status LED for the master, and then we've got the lock-unlock indicator for the GPS. So we know when our frequency is locked to the GPS and when it's not. If we're doing precision measurements, we would want to be sure that we're locked so that we have as close a frequency as we can get to what we're trying to generate. Down here's our Schmitt trigger output to shape the waveform. It's the front side. Here's the bottom side. Want to take a look at that? I like to add legends to the bottom as well as to the top. So if you have to do a little troubleshooting and get down here to the bottom of this board, it helps to be able to tell what these points are connecting to. R2 4.7K resistor and R3. And here's how the socket where we flash the slave. There's another one over here for an off-board flasher. When we build the board, we can just plug the USB to TTL interface in here to program the masters. Or if we want to play with the board afterward, access the masters and the slave after we have the LCD in place, instead of having to remove it on a cable, we can use these terminals out here to flash the master and the slave. So here's the slave flasher down there. Flash in this case means write the program into its flash memory. And I like the little CD program here. You can move things around to get close-ups and look at our power supply. It's nice to get you the perspective. Let's move her back up here. There we go. Whoop, a little too far there. Got a little bit rambunctious and too excited. There's our 805 regulator. And if we go back to the board itself, here's the board design with KICAD. That's what we just had the 3D view of. Same thing, we've got legends plastered all over it so we know what's going on. Here's where we actually build the traces, which are the wires or the connections between the different points, different components, and the different points on the board. And of course we develop that from the schematic, which is over here. There's the schematic that we started with. So it all hangs together. KICAD is a nice program. You start with the schematic. Once you got that in pretty good shape, ready to go, then you go over to the board design. PCB new, they call this. And it develops your PCB for you. Then when you want to see what it'll look like when you're finished, you go over here to the view button. And there you have it. So from these files, we developed our Gerber, what they call Gerber files. I don't know if it has any relation to the baby food company or not. Anyway, they call them Gerber files. And we send those off to Chinamen, and they develop them for us. And send the boards back to us all finished, complete, and ready to stuff the components on. Never had tools like this when I was a kid. Had to do everything by hand. I mean, I'm telling you, those days were rough. You guys, kids today just don't believe it. Having tools like this at their disposal. KICAD or KICAD, whatever you want to call it. I used to call it KICAD, but then I found out all the guys call it KICAD. So I just started calling it KICAD too. Anyway, they've got a tool like this free they get off of the internet. Technology today just blows a person's mind. I never had anything like this when I was a youngster. No sirree, Bob. I'd probably gone batshit crazy. Whatever. That's like the guy who quit the patent office in 1916. Went to his boss and he said he figured everything that ever be invented had already been invented, so he's going to quit and go do something more exciting. I always liked that story. Whether it's true or not, I don't know, but I was taught that back in school somewhere along the line. I should do it. Boards are off to the Chinaman, and I'm going to go camping in Iowa with my friends for a long weekend here now. That's what I'm going to do. This production status of how the Chinamen are coming along, building our boards will be submitted yesterday about 5 o'clock. We hit the old production progress key here. Look at there, we're 46% done with our frequency standard. See how our board's coming. It says we're in the pattern plating process now. These 15 steps right down to delivery. Let's see what that looks like. Pattern plating. You see the Chinaman over there working, doing the pattern plating step, building the PCB boards. They build them on big sheets like that, like you just saw, and then they cut off, they build a bunch of boards at once, and then when they're finished, they go into a cutting process and cut the boards apart into their individual sizes, package them up, and send them off to their customer. Quite the process. Okay, there you have it. When we get back, I hope that these boards are all finished. That's what the blank board will look like when it's finished. That's the top before we stuff our parts on. And let's see, let's take a look at the bottom. So what the bottom will be, that's before we put any parts on it at all. This is how the boards will arrive from the Chinaman, so that's pretty neat. About a week's time. A little less than a week usually, 5-6 days. All right, that's about it from here.